As another example, we are going to draw a flowchart for problem number 17 from the programming exercises that are available on your course content. And this is a problem. It says write a Java program, but in fact we are going to draw a flowchart. It says write a Java program that will perform some calculations regarding a cyclist coasting on a road. The program will ask the user to enter the cyclist initial speed, which is called v initial, the duration, which is in minutes, and the final speed, which is called v final. So here we write down that we have an input, and the input consists of initial speed, which is called v initial, and duration, which is also called duration in the problem, and we have the final speed, which is called v final. So this is input. We have a 3 input, and now we would like to see what is the calculation that we need to do for this problem. The program will then calculate the rate of acceleration using this formula. So this is the rate of acceleration. So here we have a process. In the process, we need to find the acceleration, which is a formula given to us in the problem, and next calculate how long it will take for the cyclist to stop if the initial speed and the calculated acceleration is given by using this equation. So what is also needed to do or to be performed in the process will be to calculate the time. Now for the output, we need to read what is the output. It says display the acceleration and time. So the output will be simply we display the acceleration, which is the result of the calculation from the process, and we need to display the time, which are also these two equations are obtained in the process stage. So this is input, this is a process, and this is output, and we already have the equations. Now we start our flowchart by using a start symbol. So we will make a copy and paste it here. So we need to take it, enlarge it, and this is our starting of the flowchart. And then we draw an arrow that will take us to the next step. In the next step, we have an input from the user. So we need to take an input for the initial speed, the duration, and final speed. So we need a parallelogram for displaying the message to the user. So we need to make it large because we are going to print. The message is maybe will consist of 2 lines. So enter initial speed, comma, duration, comma, final speed. And then we read these 3 variables. We read these 3 input into 3 different variables. So we will make a reading symbol in the flowchart. And we draw an arrow from the previous step to this step, and remember here we use read, and here I'm going to call the initial speed as v init for short. So here I'm going to call it v init, which stands for initial, and we are going to call the duration, and for the final speed I'm going to call it v final. So these are the variables that we need to use for the calculations. Now for the calculations, we need a rectangle for the calculation. And we need 2 boxes for a process, one for computing the acceleration and another one for calculating the time. So we have two equations. If you go back to the problem, this is the first equation, and now this is the second equation. So the first equation for the acceleration, you take the final speed minus the initial speed, you divide it over the duration. For the time, it is the initial speed you divided by the acceleration. So either you can write it exactly the same, or you can write it as if you write a mathematical equation. So the flow of control, we will go from the previous step to the process, and then we will go to display after this step. So we write the equation inside. So the acceleration is equal to, here I'm going to use the divide that we use in mathematics. So here we will have the V final minus V initial in it on the duration, so we will say duration. So here you can write a mathematical equation. No need to stick with the programming rule that for multiplication you use star and for division you use backslash. No, here you can simply use a mathematical formula into the process. Now for the time, the equation will be time is equal to, so we will use this symbol for that we use in mathematics for division. It is the V init, which is the initial speed, divided by the acceleration that we have found from the previous calculation. So this calculation, acceleration, is already found from the previous calculations. Look again here. In this equation, I'm using V final, which is the same variable I have defined for reading. V init, I'm using the same variable I have used for reading. Duration, I'm using the same variable that I have used in reading. After a process, we need to print the result. So we need to make a copy for printing the result, which is using this symbol, the parallelogram. And in fact, we need two copies, one for printing the acceleration. We need to make it big enough for the message. And we need another one for printing the time or the duration. So we need to link them together. So this is the flow of control. And the first one, we will print acceleration is, and we need to print the result from the calculation for acceleration we have found in the process stage. And the variable was called acceleration, so we use it here, acceleration. Now for the time, we print time as, and simply we print the variable that has the time, which is used in this calculation. After we finish from the printing the result, we need to end our flowchart by using the end symbol. And this will end our flowchart. By looking at the flowchart, so we are starting here, and then we read the initial speed, duration, and final speed, and we put them in three variables. The first is called V init, the next one is called duration, and the other one is called V final. So use these names into your calculations. The first calculation we have for the acceleration, which is this equation, and for the time, which is this equation, and these equations are given in the problem. So after we finish from the process, we print the results for the print, for output phase, and then finally we end the program.